Hello everybody. First I'm going to show you normal packet switching. This is our network topology. Uh, this is our client. This is our server. Client will want to receive 100 megabyte file. Uh, we can see that here. It will request the client host one. It will request 100 megabyte file. This is the initialization file. This is the net file. Let's see. Because they are connected with Ethernet, the data rate, the available data rate that I can assign were limited. So routers are connected with 100 megabyte Ethernet, and the receiver and sender are connected to the routers with 10 megabyte Ethernet. Let's see. I define this and little bit IP configuration here. Okay. TCP basic client, TCP generic server app. Server will send a 100 megabyte file to the client. These are little bit they are not trivial, but they are not important. Let's build and let's run it. Okay. This is our simulation. These are the routers are using RIP protocol for routing. We can see that. So RIP protocol will route the least hopping path. So the least hopping path from H1 to H2 is like here. We will be able to see. Okay, sinyal acknowledge is coming. If I move forward, we can see that okay, we can see the request here. We can see the data flow from H2 to H1. Let's see that. We can see that. H1 sending TCP acknowledge, and H2 is sending the 100 megabyte file. We can see the TCP acknowledged here. And this is it. This is our normal packet switching. Let's wait for the simulations finish. By the way, let me talk about some things. Simulation time limit is 250 seconds. but idle interval time is 200, so this means it will during simulation time it will only request one 100 megabyte reply length, 100 megabyte file. So let's see what happens to our. It's about to finish. It's take a little bit time. Okay, it's finished. We can see here one connection open by H1. Opened one session, sent 350 bytes in one packet. This is for the request package. Received roughly 100 megabytes in this number of packets. H3 and H4 didn't do nothing. H2 was the server. It did send 100 megabyte in one package. Received 350 bytes in one packet. Okay. Yeah, this was for packet switching. Now I'm going to talk about virtual circuit switching. Let's close this. By the way, I'm recording, right? Okay, I'm recording. Okay, let's see virtual circuit. I couldn't do Ethernet switch because the MPLS this here LDP MPLS router doesn't have an Ethernet gate, only have PPP gate, and Ethernet switch doesn't have PPP gate. So no matter what I try, I couldn't connect them. So I just didn't add Ethernet switch. Let me show you something here. These are the configuration files. This is for the host one. Let's, for the sake of example, check them. This is for the configuration of router 1. I defined here its interface and its interface address. This is for the LDP label distribution. Okay, and this is for the host 1. This is just an example. It routes here, this one. This is the address of PPP0 here, yes. And host 3 should, yes, host 3 is talking with PPP0 of router 1, 2. Okay, this is our configuration files, and let's see net file of virtual circuit. Again, our channels. Here I could do I could arrange kilobyte per second in channels, but for fast simulation, for fast finishing, I did use again 10 megabyte per second channels. This is LDP MPLS router. You can see that. This is for the virtual circuit switching. We can do virtual circuit with MPLS and LDP protocol. These routers are MPLS capable. We can see the topology here. Let's check here in a file. Again, we have a TCP file. It requests 100 megabyte file. This is for the delay, for randomization. Again, our share files, configuration files. Let's start it. This is 2 times faster than the packet switching, by the way, interestingly. Okay, let's start it. It will give an error because there is not routers are not ready. They are sharing information. They are sharing labels. LDP hello, we can see that. Oh, it sent. Routers are now the way now. It wants to synchronize, and we can see synchronize acknowledgement. Okay. TCP session is about to start. Okay, it's sending its request package. Again, host 3 and host 1 are idle. They are not doing anything. And the file began to send. You can see that. Let's wait. Finishing. It will finish around 90 seconds. Like I said, 2 times faster than the packet switching or MPLS protocol. MPLS protocol can serve. Oh yes, it's finished. Again, we can see similar results here, like the packet switching. Okay, let's close this. In routers gates there is drop tail queue. Packet capacity is 10. So Omnet is pretty good simulation tool for us. First, I did try with UDP basic app and UDP sync to understand how topology work, testing for the topology. Then I implement TCP basic client app and TCP generic app. And for more detail, you can check for my report. Thank you for listening.